Hi, C++ programmers. This is a discussion of the spec for Program 7, the group project called the SpeedTrap. What you're looking at now is my form that I created for the SpeedTrap. As you can see, it has my header at the top. Okay, I know it's not P5. That was what it was when I assigned it before. Here's a title that gives the information on what we're doing. There's only one button on the SpeedTrap form, and it's called Check Speed. We'll talk about that in a few minutes. These are the images that I use depending on what's going on in the program. Have someone with radar checking the speed. We have a chase car who's ready to go turn on his lights and sirens and stop the speeder. Here's a car getting a speeding ticket and a poor fellow going to jail because he didn't have a driver's license. Serves him right. Maybe if we did that, we wouldn't have so many people in New Mexico driving without licenses. Anyway, part of the spec says that we will have status messages that are printed to the screen. And so what I have here is the vehicle number we're looking at, the speed of the vehicle, whether it has a driver's license, and then the log file names will be written down here. Okay, so one of the things that we need to know is what happens when we click check speed. Let me first take a moment to go over the myform.h code. We need to include vehicle.h, SpeedTrap, traffic generator, patrol officer, and utility functions. I also have string stream. Up here before the public ref class, I've created the traffic generator object and a SpeedTrap object. I've also made a local count variable to count my vehicles, because as we know, we're going to run 50 vehicles. In the constructor, I get the radar cop's name out of my name list, and I set it into the text underneath that picture. I set all my pictures, my scenarios, okay, my pictures, to false. And here is the log file. This is what's going to be printed on the lower left of my form that describes the log files. Okay, moving on. We'll get through all this, and here is our check speed button. If the count is less than 50, then I set everything visible equal to false, as it should be before anything starts, and then I generate a vehicle object, vehicle V, by calling traffic get vehicle. Traffic is the traffic generator object, and it returns a vehicle. I increment the count and put the count on my label, in the label on the form, and then I check the speed of the vehicle. The way that I do that is I call v.getVehicleSpeed. Okay, so that is in the vehicle class. I toString it and add it to the label, and I check to see if the vehicle has a driver's license or not and put that on the form. Then I call, and this is one of the most important methods to get things going is trap.checkSpeed. This is the SpeedTrap object, and I'm passing it the vehicle object. Okay, if it's less than 25, the speed that is, then I show the image that that the driver's a good citizen. Okay, otherwise I retrieve a patrol officer object. I get the name of the chase car cop from the SpeedTrap method, and I concatenate the word officer to it because they are officers after all, and I create a string and put it into the label. Then I look at the chase car, get a picture for the chase car. If the speed is greater than 25, which means they're speeding, then we're going to say the name of the officer, gives a ticket for how much the fine is, and the fine comes out of the SpeedTrap object. If the SpeedTrap object says that the driver has to go to jail, because the SpeedTrap object is the model that's going to take a look and see if the vehicle driver has a driver's license, then I'm going to display the fact that the driver's going to jail and what the jail fee is. Okay, so that's it on the form. The form just displays the vehicle that is generated. Right here is where it's generated, and here's where it's displayed, and then it displays the results of whether or not the driver was speeding and whether he or she has a driver's license. So now let's take a look at the classes we're going to use. Okay, we'll start with the vehicle class, and each vehicle has a speed, a driver's license number, a vehicle license number, and a driver name. We have a default constructor and an overloaded constructor. We can set the speed, set the license plate, the driver license number, and the driver name. We can get the speed, get the driver's license, and get the vehicle description, which is a formatted string. So now let's see what vehicle.cpp might do. Basically, here's the default vehicle. Here is our overloaded constructor passing arguments or parameters into the class variables, and here is the vehicle description. Okay, next we're going to look at the traffic generator. Okay, the traffic generator has two file streams, an input stream and an output stream, and it's part of the class variables. We're going to keep the output stream open so that it can write a log while it's creating the 50 vehicles, because they need to be in our traffic generator log. I used a different random number generator. We can talk about this in class if you guys want to. We can use the new C++11 random class, or you can use rand. If you use rand, you need to seed it in the constructor of the traffic generator. And then, of course, you can use it anywhere that you are. We have the number of vehicles created, the license plate number, the speed of the vehicle. I made an array of state abbreviations. What it says is that 70% of the cars are going to be New Mexico cars, and the other 30% are going to be from at least 5 other states. So to me, that says that the cars are going to be from 6 states. So I made an array of 6 state abbreviations for the driver's license. The car license numbers. And there's a state index for when I figure that out. Driver's name, I have an array of 50 drivers. I created a log file, not a log file, a file of driver names. Looks like that. Okay, so the input stream is for reading my file of driver names that I'm going to need that are assigned into that index. Driver's license number, time made and date made, that comes off of system date and time. Description is the vehicle description. And then here are some private methods. Choose vehicle speed. We're going to choose that randomly. Make license plate. We're going to choose the license plate randomly with 3 letters and 3 numbers in the license plate using the random function. And then make driver's license, which will be chosen randomly. 20% of the vehicles will not have valid driver's licenses, so that needs to be one of the options. The driver's licenses will be from the same state as the car and will have 9 random numbers in them. Then we have the file name. I have a bool for whether the driver file name is open, a bool for whether the log file is open, and then I have a method to open the log and write the log. We will open the log once, and then we will write the log every time we create a car. Here is my default constructor. My destructor, which I will use this time. In the destructor, which is called right before the object goes out of scope, we're going to write totals of the vehicles into the log. Here is my moneymaker, vehicle get vehicle. Remember, that is the method that's called from the form to generate a vehicle. Here is the bool to get whether the log file was correctly opened, and to get the file name, and to get whether the driver name stream was opened. So let's talk about where these things are going to happen. All of the initialization for the class is done, interestingly enough, in the default constructor right here. Okay, so what are we going to do in the default constructor? We're going to initialize variables. Now, you can initialize variables, as you know, here in the .h file, so that's fine. You can do that here also. In addition, I'm going to assign values into my array of state abbreviations. I'm going to get the time made and the date made. These I got as string dates and time from the C++ time function, date and time function. I'm going to seed my random number generator in the constructor also, and I'm going to read, I'm going to use my IFStream input, and I'm going to read the file for the driver names and fill that, there it is, fill that array, and then I'm going to call openLog. So the default constructor does a lot of things in this program. While we're talking about openLog, that method uses a string stream to create the file name for the traffic generator log. And so it is the name of the traffic generator log is trafficgenlog _date_time.txt. So that is its birth date or birthday. Then the log file is opened and an initial header is put on the file. Mine says Yvonne Nelson CIS 2275 program 7 it would be, traffic generator log file, and I say the file was created on the date and the time. And that's it for openLog. The log is not closed. We leave it open because we're going to keep writing in it. Okay, the next private method we can talk about is getVehicle. Oops, that's public, not private. Okay, because getVehicle is the method we're going to call first. GetVehicle first calls, well, I guess it doesn't have to be in this order, but this is the order that I used. Choose vehicle speed, then it calls make license plate, then it calls make driver license, make driver name, and finally in vehicle get vehicle, it then uses either the default constructor and a lot of sets or the overloaded constructor to actually create the vehicle object. At that time, the vehicle description is made and assigned into the description string, which is up here somewhere, string description. And we increment the number of vehicles made, because count is there they are, vehicle count, class variable, because we made another vehicle, and then we write in the log. We write the information for the vehicle we've just made, and then we return the vehicle. So there's a lot going on in the getVehicle method. Let's talk about the individual private methods. Okay, let's start with choose vehicle speed. This isn't too bad. We choose the vehicle speed using the rand function, and the spec tells us that the speed range that we're going to generate in is from 16 to 85 miles per hour. So that's pretty straightforward. Make license plate is a little more complicated. you need to figure out how to make 70% of the license plates being New Mexico license plates, and then choose random letters and numbers so that you end up with something that has, you know, like New Mexico plus the plate numbers. And the plate number is going to be like ABC 1, 2, 3. 3 letters and 3 numbers. But this is just a combination of random numbers put together. Okay, make driver's license is similar. We know that the state for the driver's license will be the same state as the license plate, so that's taken care of. Then we need 9 random numbers to create the driver's license number, remembering that those random numbers are all single-digit numbers. I guess you could maybe make one 9-digit random number. That would work too, but I always have fun adding all the single numbers together. It's up to you. So the driver's license number is the state abbreviation, which we already have, plus the 9-digit number. The method, make driver name, will simply be the first or the second. It'll be the index of the count driver name in your array. You can randomly choose those, but if you do that, then of course you have to check and make sure you don't choose another one. So I'm okay with you just going through the driver names that you have listed in your array in order. Okay, so we have everything we need to create our driver's license, our vehicle. We have the speed, the license plate, the driver's license, and the driver name. The only thing left to talk about is opening the log. In order to open the log, you have to create the log name. I think I told you this already. And start the log with the initial entry. Write log is another private method, and that's called every time you create a vehicle. And basically what it does is it writes a line that has the vehicle count number, the time that it was made, and the vehicle description. Okay, that's it for the traffic generator class. Let's move on and go to the SpeedTrap class, which is the other major class whose object you use on the form. So let's see what's in there. We have the radar cop, who you can, if you want, you can make him one of your array. I made him a separate object. He has a name, and then we have names for all of the chase cops. I also have a file called police officer names that I made up, or you can certainly use some of the names off of your long list of names. And so what we're going to do is read those names into this array. And we're going to do that in the method fill PO names. We also need to have badge numbers for all of our police officers. And we're going to create and assign those numbers in the private method assign badges. We need to know who the current, the index of the current cop on deck. That's for the chase cop. So it'll be one of these guys and his name. Then we need methods to, or variables, sorry, to keep track of things like the total money collected, how much the extra fee is for jail time, the fine for speeding, whether the driver's license is valid, which would tell us whether the person goes to jail, B, speeding, which if it's is true if the vehicle is speeding, the number of vehicles ticketed, the number of vehicles sent to jail, although I guess it's really the driver who goes to jail, and the fee structure. The fee structure is another file. This is my fee structure. These are the different ranges for speeding and how much the speeding fine is. Our spec tells us that the speed ranges start at 25, the legal speed limit, and continue in 10-mile-per-hour increments until 85. So that is the, those are the ranges. Then we have an output stream for the log file for the SpeedTrap, a bool, to say whether the SpeedTrap is stream is okay, the birthday of the SpeedTrap, and the log file name. So then we have an open log file and a write log file method, just like we did with the traffic generator class. The write log file will gather the information from all the patrol officer objects and creates a report that says the time of creation, total money collected, total vehicles passing through the trap, total vehicles cited for speeding, broken down by speed range, and total vehicles without a valid driver's license. So this is a summary type of file. Here is our default constructor, which gets the current time and sets the string for the birthday, generates the file name string stream and initializes member variables, and sets the police officer names. What this means is that after the log file name is created and everything is initialized, then we call open log file. We call fill ticket speed and fees. We set the ticket speed range into the radar cop object, and the ticket speed range is, yes, it's an array, so we send the array to the object. So the radar cop can know the ticket speeds and know whether someone's speeding. Then we call fill PO names to read our officers' names out of the text file and assign them into the array, and assign badges. So let's talk about those methods. Fill ticket speed and fees, you simply make a loop and for each speed you decide how much your speed range, you decide how much you're going to charge for the ticket. Fill PO names, again, use the IF stream, open your text file and read it into the array of chase cops. Assign badges. Well, the badge numbers are 3 digits long and they are randomly assigned. So you create a random 3-digit number, and for each chase cop you set the badge number. And So you have a loop for all 50 chase cops. Open log file does just that. It just simply opens the log file. The reason it doesn't, you can write an initial statement, but you don't need to, because that's going to be written in write log file. So write log file writes a header statement, name of the people on the project, CIS 2275, program 7, and then it gives the summary of everything that was described up here that goes into the log file. That's why we're keeping all these variables. These are what's going to go into the summary. The check speed method is the important method in this class. We pass it a reference to the vehicle that was created. Every vehicle is checked for speed. If it's speeding, it's checked to see if it has a driver's license. And if it does not, then it is sent to jail with the next available patrol officer. So this is when we assume that it takes the officer a while to drag the speeding, law-breaking citizen who has no driver's license to jail, and another chase cop takes his place. The rest of the public methods are pretty straightforward. They're getters, and you can see that they're all inlined. The destructor for the SpeedTrap calls the write log function and closes the file. Okay, what do we have left? We have the patrol officer class. And let's see. Again, we have a log. No, we don't. 2 log files are enough. We do not need to keep a log of the patrol officers. They are summarized in the SpeedTrap. So each patrol officer has a badge number. The radar cop has a badge number. The radar cop has a name, and each chase cop has a name. We have the index of the speeding range, and here is the ticket speed range that is passed to the radar cop. We have our constructor for each patrol officer. We set the ticket speed range. We set the chase cop's name, the badge number, and we can have a getter for getting the range. We can get radar and chase cop names, badge numbers, and then we have our important method, a vehicle check speed. This is different from the one in the SpeedTrap, and I know the names are very similar, so you have to be careful. So, whereas the SpeedTrap gets the call to check vehicle speed, the SpeedTrap asks the radar cop to check the vehicle speed by calling radar cop vehicle check speed. So the actual speed check is done in the patrol officer class. Once the radar cop receives the vehicle reference, that means he can get the vehicle speed, check it against his speed ranges, and sees if the person is speeding. He can then write to the log whether they're speeding. And once he's determined that the driver is speeding, he then calls take to jail to see whether the driver's license is valid. So take to jail sounds definite. I guess it maybe it should be called should we take to jail or something like that. When we call take to jail from the check speed method, we are calling it using a chase car, a chase cop object. So remember, both of these calls, to vehicle check speed, which is called on the radar car cop object, and take to jail, which is called on the chase car cop object. Sorry. Those are both called from the SpeedTrap's method check speed. So that's how the speed is checked, and that's how the whether or not the driver's license is evaluated. So the patrol officers do their job. The radar cop checks to see if the driver is speeding and returns that to the SpeedTrap. And if the driver is speeding, then the SpeedTrap will call chase cop take to jail to find out if the driver has a valid driver's license and whether or not that person needs to go to jail. Okay, well, that's a fairly long summary of how the program is put together. I hope it helps you in your coding. As always, if you have any further questions, you can ask me in class on Monday or email me. Happy coding! Bye.